Hi, welcome back to Mini Rust in Rust. This is video 31. We are building a little programming language that looks exactly like Rust as far as we can make it so far. We're writing that code in Rust. It's going to be an interpreted language, so it's not going to end up being exactly like Rust, but for the moment we haven't made any decisions that deviate from that, but we will. Okay, so what's currently driving our coding at the moment is we have this little example, this little snippet of code, and we want it to lex and parse and type check and evaluate the same way it would if this was being compiled from Rust source code. And what we did last time was we got to this weird situation where our parser expected there to be a semicolon after the while to know that this was the end of a statement, and there wasn't a semicolon. It got confused. We changed that. So now we're just going to unignore this test and see what goes wrong next. So we run our tests. We see that it goes wrong in the type checker. Now, I had a quick look at this before I started recording, which is why I'm not surprised by that. But basically, we now got to where I got to, right? So no, nothing else up my sleeve. So basically, line 188 of the type checking code is where we hit this to do, which basically says if you're type checking a syntax tree and you hit a while keyword or a while block, what do we call that? A syntax tree that is a while expression. Then fail saying to do. And what we want to do instead is something like what we're doing up here. So for an operation that's like a plus something, or an assignment that's like a let something equal something, we just call out to another function passing the information through. So I think we should do the same thing here. We'll call it type check while. Like so, and I think we're probably not going to do much about actually doing any type checking here. We'll see what we think. I mean, the type of a while loop will be, well, that's a good question. It's a good question. Can we do a quick check? Let's go to, let's make ourselves a little thing, type of while, let's call it. And let's just write something that tells us how we find the type of a while expression. So no, we won't download the Rust Analyzer right now. So we're going to say let x equal while. What should we do? Well, we could do, if we did while false, that would really confuse it, wouldn't it? So let's just say while a is less than 2, and inside we'll make a bigger, and we better let a be something. So a situation like this, what is the type of x? Or can while loops just not have types? Okay, so here the type of x is the unit type. Let's print it out, shall we? Why don't we just do a debug? Like so. That's not how you spell. That is how you spell debug. All right, so we need a semicolon because it's now part of a let statement. Okay, that's interesting. I wonder how that will affect the code that we wrote last time. We'll see. Okay, so the type of x is unit because this while loop doesn't produce any answer. How would I make it produce an answer? What if I said something like that? Would that then produce an answer? Well, now it's confused because so basically, I guess a while loop expects the stuff inside it to be of unit type. And we didn't mean that. We want you to kind of like return a 10 out of this loop. And now it says a while loop can't have a break like that. you can just break out, and that will work. So we could do that. But now the type of X is just unit again. And we could say maybe 10 first and then break. But that's not going to work because that's a statement that's not going, that 10 is not going anywhere. All right. So it looks to me like a while loop can't actually return a type. I think that's what we're concluding from this. Do leave a comment if you know better. But I think what it's saying is if you were going to return a value from a while loop, this would be how you do it. But you can't. So you can do a loop, which is kind of interesting, but not for now, right? So we can do loop. And now X is going to have type I32 because we broke out and put 10 into X. I guess the reason why we can't do it with a while loop is there's another case. Other than the situation where we get inside the while loop and we return a 10, the other case is what if we never get inside the while loop? Can you put an else on it? While else loops are not supported. Right. So, all right. So if we could do an else to like cover the case where we never get into the loop because A was already too big, then it would make sense for X to be able to have some kind of type because then you'd cover both cases. But it looks like you can't do that. So that all this goes to mean we don't need to care very much about what the type of our while expression is. Oh, sorry, I guess maybe we should call it a while statement in this case. Interesting. But we might want to do some other type checking inside here. Like, for example, this conditional expression should be a Boolean expression. And this block should have type unit we've just discovered. So maybe we could check those things, or maybe we'll have to leave that for later. Let's see. All right, so let's have a look at type check operation, and we'll do something similar to that. Oh gosh, there's a lot in here, isn't there? I guess that has a left-hand side and a right-hand side and some stuff. Type checking a leaf doesn't do very much at all. Or a leaf is just like basically like a number or something like that. What about an assignment? How complicated is that? Not too bad. Let's copy the assignment one and then we'll check back at the operation one later if we need more clever stuff. All right, so this is going to be called type check while. And the arguments that it takes are a condition expression, which should be something like this expression here. I think it was called condition expression, wasn't it? Let's just check. Yep. And the other argument was called block. And what will the block be? So the condition expression will be a syntax tree, because the syntax tree is just like some piece of syntax. And I think the block will also be a syntax tree. And we want to type check each of these things. We haven't passed in file contents. Well, that's our first mistake. Let's pass in file contents. File contents is basically like the source code that we're type checking. So we need to pass that in here. And it looks to me like we are dereferencing expression before we pass it in here. Do we need to do that? We're not doing that the other places, so we'll ignore that for now. There's probably something special about whatever that was. Okay, so we're going to type check the condition expression, and we'll get back a type syntax tree. All right, fine. So that's fine. But we also want to check the type of this condition expression. So now that we've got back a typed syntax tree, what can we do to it? Obviously, I've forgotten all the code I wrote before. Okay, so it has this thing called type constraint. And it should be of type Boolean. And a type constraint at some point in future, type constraints are going to work in two directions, right? So we're going to be able to say, because you're an expression in a while loop, I know you must be Boolean. But right now, I feel like we can only say the other way around, which is because of whatever values you have inside you, I know you must be Boolean. Because you're a less than or whatever, I know operation, I know you're a Boolean. So let's just have a look at what happens with this type thing. Note that we don't actually have a Boolean here. So I think I remember what happens with these type constraints, that we want to combine the two together, where the first one is, I know that this has to be a Boolean, and the other one is whatever type checking I've managed to do on the contents of this expression. I'm just not remembering well enough how all this works and not wanting to solve this entire problem now. Well, all I want to do right now is get the while statement working. And I note that there is no bool here, so we haven't actually even made up a type constraint called bool. So I think what I want to do is add a to-do here that says to-do. Check that condition expression is Boolean, and just leave it at that. All right. And then I think we're going to do the same thing for block. So block is going to be something that we type check, like so. In this case, we want to check that that block is unit. And then we're going to return. So the whole point of this thing is that, excuse me, is that we take we get given a syntax tree, or rather they're sort of the contents of a syntax tree, which we know is a while, and we turn it into a typed syntax tree. So that means we're going to return a typed syntax tree of type while, and it's basically going to be constructed out of these two things that we've made, the condition expression and the block. And does this already exist? Probably not. So this is a function which we want to exist within typed syntax tree. Oh, we can't call it while. We have to call it, let's call it while underscore. We're going to make that function, and it's going to return a type syntax tree of type. What is this? This is a type constraint. Okay, so the type constraint on this is going to be unit, because a while expression always returns unit. And the note, I think, well, I guess we'll check whether this all works out, but I think this is right. And a type syntax tree of type while, which does exist, which takes a condition expression in a block. And it should be, we need to wrap this up in a syntax node, because that is the way I'm sharing code between the type syntax tree and the untyped syntax tree. And I've done that wrong. I think I'm really confused. All right, what I want here is a syntax node of type while with the condition expression block. Yeah, okay. But that's what I wanted. And we need to box these things up. So let's check what we're doing in a similar function. There must be a similar function somewhere around here. Yeah, like statement is a similar function. An assignment. These things don't box things up because they're already boxed. Maybe I should have boxed them on the way in. So this takes in, well, should I take an example? Oh, a box of self, because we don't actually know what it, yeah, okay. So this needs to take in not a type syntax tree, but a box of self, because I think, if I'm right about this, this is code that gets shared between typed and untyped stuff. All right, so let's go back to where I've broken it by not boxing things up and check how other things. Yeah, all these other things, they box things up before they pass them in. So it seems like probably the right type of thing to do. It'd be good if I remembered anything ever, wouldn't it? Okay. I think we'll find out if I've completely misremembered this when it doesn't work properly. Although the type checking is so bare bones at the moment that it may not. Okay. So have I done enough now to make this code get a bit further? Yes, because now we have a type check error in a different place on line 192. So what happens on line 192? Okay, so now we've got this thing called a block, which has also not been dealt with in type checking. Fine. Does that imply that we should have a different type here on block? I guess not yet. We'll think about it. All right, so let's do the same thing again. We'll create a function called typeCheckBlock, which takes in the file contents like last time and the statements and the final expression. So this is when we were constructing block, we vacillated a bit between whether the final expression should be just one of the statements, but statements should always have a length at least one or not, and whether like there always should be a final expression, even if we have to kind of insert a fake one, which is just unit, meaning nothing happened inside there. Hang on, I got to talk a lot more. I'm waffling on without really explaining. So let's think about what a block is. A block is a curly bracket and then some stuff and then another curly bracket. So there's a difference between all these things, in all these blocks, between all the statements in the middle here versus the final expression, which is not a statement, doesn't have a semicolon, which gives the block a value. So if this was an if, for example, then the answer from that if in this branch of the if would be 5. Now, we've already established that while loops can't have any kind of return value in that sense. So arguably, we shouldn't be tackling this whole business around what a block is while we're doing a while loop, because it turns out, quite fortuitously actually for me, while loops are easier than other types of block. And maybe that means this block thing, which has all the earlier statements and then the final expression, is not actually an appropriate thing to use for a while loop. But I think it probably is, because I think it will help us make better error messages. Because if we do stuff like this, we get an error saying well, maybe we would get that anyway. But anyway, it might be useful to us. Let's see if it makes trouble for us, and if it does, we'll change it. Generate a function called typeCheckBlock. We'll put it next to typeCheckWhile, shall we? Make life easier. Okay, so this is a thing for basically looking at that parsed block that we've got and checking its types are okay. And I think the main thing is that we need to check that. Should we be calling typeCheckBlock here? confused. All right, so let's think about it in terms of assignment, because assignment has multiple things here. It calls type check tree for the right-hand side because that is just any old tree. And what does type check block take? The thing is that type check block knows that it gets called from type check tree. So if we call type check tree, we'll get into type check block anyway. But the question is, should we jump straight into type check block? And the answer is no, because we don't have the statements and final expression that are needed to get there. So if I go back in here, we've only got this thing called block, which we know is going to be of type block unless things have gone wrong. But we haven't extracted the bits out of it. So the pattern is you call type check tree, it extracts the bits out and it calls into here. So we'll do that. Now, statements is a vector of syntax trees, all of which we believe are statements. And then final expression is just that final expression. I don't think we have much type checking to do on any of this. We want to change this to be a vec box of typed syntax tree. So we do need to go through each of these statements and transform that into a typed syntax tree instead of a syntax tree. So we've got to do some work, but I think it's going to be mostly fairly dull work. So we're going to do typed syntax tree. And we're going to make a new function on it called block. And block is going to take in some statements and a final expression, final, like so. And does that function exist? It does not. So let's make that function, but let's not use what it generates for us, because it needs to be a vector box of, I think, self and a box of self which returns a self. Because again, this code is used for both typed and untyped syntax trees, which is making my life confusing, but hopefully is worth it. Let's move this up to be near the code we just wrote in that while function. Okay, so this is going to return a self, because all of these things return a self, where the type is going to be I guess the type of it is going to be whatever the type of final expression is, right? And the node is going to be syntax node of type block, which uses the statements and the final expression that we passed in. So I'm not 100% sure. Oh, well, okay, there's some problems here. All right, so we got to clone this. Is a type constraint copy? Don't know. Yeah, so I'm not 100% sure that the type of a block is the type of its final expression. No, I'm 100% sure of that sentence I just said, but whether this is where we figure that out. I'm thinking maybe it is. Okay, a lot of these pass in a type, which is kind of interesting. Should I be passing in a type to these other things? Let's see where this happens. So here, we're passing in the type of unit because assignments always have type unit. Why are we passing that in? Because we know it, right? Whereas a leaf token, we pass in the type because we don't actually know what its type is. It could be any of these things and actually some other things as well. And we need to go and, like here we're hacking to say it could be anything because it's a symbol. So that makes sense that we pass in the type to that. And for an operation, we pass in a type. Because we're cheating and saying the operations have the same type as the left-hand operand, which is definitely not true for Boolean operations. So That's definitely not going to work. But yeah, again, there's a reason why we're passing in the type. So it feels to me like for the assignment, assignments always have type unit. So why are we passing in the type? Let's not pass in the type. And instead, type can be unit, just hard-coded in here. And that matches what we're doing elsewhere in the new code we just written. So statement, again, when we call statement, presumably we always pass in unit because statements always have type unit, right? So let's just hard code it. And this will come back to bite us, I'm sure, if this is wrong. Now, I've caused ourselves some errors here. All right, yeah, we don't need to pass in that. We don't need to accept that argument because we're not using it. I guess the same for... No, we did delete it from here. What else? All right, we're calling this from some other places. We're calling block. And it's expecting a box. And we need to box these up. Oh yeah, this is because we haven't actually written our code yet, so we don't have to worry about those errors yet. All right, so this one we don't need to pass in unit anymore. This is just test code. Any more like that? No, are we down to a reasonable number of errors? Yeah, we are. Okay, good. So now we get to the point that we haven't actually written the code that turns a syntax tree into a type syntax tree. So let's get on with it. So we're going to say statements, which is a vec, is going to be statements dot iter.map dot collect, and then we just have to think about what we do in between. So now we've got a box of syntax tree, which we'll call T, and we want to turn it into a box of type syntax tree. So I guess it's going to be box new of type check something. I guess type check tree T, right? Oh, but we also have to pass in file contents. Maybe we need star T or something like that. Expected a parser syntax tree and found a box of parser syntax tree. What's the type of T then? It's a reference to a box of syntax tree. What if I did star star? I mean, I don't see why one star wouldn't be enough. Now, what are you complaining about? Oh, it's a result. All right, so we need to question mark it, but what if we said this was a result of vec? I'm going to have to explain myself if this works. Does that work? Oh, well, I have to say what type of result. Comma get error. It does work, I think. Yep. All right. So let me explain myself because this is actually cleverer than it looks. So what we're saying is go through statements. Iter means just iterate through statements, and then for every statement you get, run this function over it, and then collect it up into something. And the magic is in the collect. So the function that we're passing to map just takes in a takes in a syntax tree, wraps it in a box. But the main thing it does is it calls type check tree. Type check tree takes in a syntax tree and a file contents, and returns a result of typed syntax tree. And now, do we really need 2 stars? We do. Okay. I guess we could get rid of one of them by doing this. This might make me a bit happier. Yeah. Okay, don't worry about that. That just means pattern match on a reference to something. So we don't need to dereference it twice. Anyway, point is, type check tree returns a result of type syntax tree. So now we've got an iterator of box of results of typed syntax tree. Should we double check that? If we get rid of the type declaration here, just say, get me this thing. What is statements? Statements is, it doesn't quite tell us. Oh yeah, implement, oh gosh, this is new. This is really cool. Implements notable traits. It implements an iterator where the item is a box result of type syntax tree. That's cool. So, if I put all the types back, what I'm saying is, given that you've got, what have I done? Okay, given that you've got a box of results of type syntax tree, I would like, a box of results of vec. Hang on. What was it? It was let's do it again. Given that you've got an iterator over things which are a box of result of type syntax tree, I want you to give me something which is a result of vec of something. And I haven't said what's in the vec. I've just let it figure it out for me. That's what the underscore means. And it's been so clever. I didn't even know it was this clever. I was thinking that we didn't have this box here, so I didn't realize that it would be so clever that the collect thing here actually can figure out if you've got a iterator of box of result of something, when you collect it and you want the outcome you're asking for is a result of vec of something, then the first time one of them is a failure result, an error result, stop what you're doing and turn this into an error of vec, an error of this miet type. But if none of them are errors, give me back an OK of vec of box of thing. Like, it's been really clever to figure that out. And by the way, if and when we do all the proper type stuff in Milk or Mini Rust, we're going to need to know how to code that uses this type declaration here to tell us, or all the way along here as well, to tell us what collect really means and call the right version of collect. So, goodness me, that's going to be hard. Right, and the other thing is final expression, which is much easier. So we can say let final expression equal a new box of the result of calling type check tree on final expression. And then we probably need a question mark somewhere. Well, we've got to dereference final expression, and after we call type check tree, we want to call question mark. And there's a problem with statements. Oh, yeah, we should do a question mark on statements. Okay, did this not work as well as I thought it could work? Okay. It just would have been really, really smart of it to do that. It's saying it doesn't know how to make this. Well, I guess we could try. Basically, I shouldn't be boxing it yet, I think is what's going on here. Let's just not box it. So we're going to box it later. No, it still doesn't know what to do, right? Or should we put it back to how it was? Yeah, I had a question. Yeah, okay. So I was really getting ahead of myself, thinking that it knew what it was doing. I guess. Well, no, actually, it could work. Okay. So now I've got the situation where statements is a result of vec of blah, and it should be a vec of blah. So if I get rid of the result thing here and just put the question mark in, I feel like this is going to be already going to be too hard for it to figure out. Yeah, so let's put it back. And get rid of that question mark and that question mark, and we'll just do this. Let statements equals statements question mark. So that's just saying, first of all, collect it into this result type, and then just immediately return if it's an error. But this is still not the right type because it's a vec of type syntax tree, and it should be a vec of box type syntax tree. So what if I try and box it? Now, yeah, if this doesn't work, it shows that I had too much faith in the magic of collect, that it could somehow do this. That's right, it can't. So I guess, well, basically the cleverness of collect is that it can take a list of results and turn them into a result of lists. And I want to use that cleverness to get me a result, but I also want to box everything. So I guess I could do only box it if it was. Can I do this? Is that a thing? Boxed? No. All right. So let's do. If type check tree gives us an okay answer, then we want to do something to it. Let's call this thing TT for type checked tree. Let's put it inside a box if it was okay. Otherwise, it's just an error. Why is it complaining? Because I couldn't do the thing I was showing off with earlier. Instead, I'll do this double thing. No, the problem is, okay. I'm not sure what the problem is. So, all right, at this point where I'm finding myself getting wrapped up in knots is where I will often stop and write myself a for loop and see how bad it is. So, we don't like it because it's got mutable stuff in it, but other than that, this is going to be so much easier. So let's just see how it looks. Because basically all this stuff here is all showing off about how you can keep loads of stuff in your head. Let's just not show off. Let's just do, let's call type check tree on statement, and let's just make a thing called statement, which is the result of type checking statement, and then that returns a result which we can now question mark in a nice straightforward way because we're not inside a closure. So if type checking the tree fails, then just immediately quit from this for loop. Otherwise, put the answer into statements, but first we'll box it. Okay, and I think, okay, hold on, we got two things called statements, and in this case, that ain't gonna work. So let's call this, what is this? This is the type statements. Yeah, so the point is we had a clash of names. Statements. Oh, we've written that already. Like so. And this needs to be dereferenced to be able to be passed into type check tree. And statements has the wrong type for some reason. Type check tree should return a type syntax tree, which we then push into type statements. So oh, I had to rename it here too. Thanks you for everyone who was yelling at the screen. Okay, so look, this makes me really sad because we have a mutable vec, and therefore, I don't know, we might do more allocations than we really need to or something. I mean, I could always give it the capacity of statements, and then we know that we'll do only one allocation. But yeah, we're building it up gradually by looping through and manually doing the work instead of doing that lovely map and collect thing, which is so nice. And is it because it's like a known pattern, the compiler can optimize it better or something maybe. But in this case, we were really being tripped up by the fact that we wanted to stop when something went wrong, which is what this question mark helps us with. But we also wanted to box the thing afterwards. And so I feel like the only way to do that, the way we had a way to do it, but it wasn't quite working out. It was just getting massively complicated. Once I've got a closure inside a map that in self calls map on something else, that just feels like too much. Yeah. So instead, I just prefer this code. Stop apologizing, Andy. All right. Where have we got to? We now have a while statement and a block, both type check. We don't do anything clever. So the question is, we had a to do up here, which was check that the conditional expression is Boolean, check that the block is unit. Here, I feel like in the while case, this is the same. Saying that check the block is unit is basically the same as saying that check the type of this block that we just type checked, and the type of this thing is what we did in here, which is basically says the type of a block is the type of the final expression in block. So that's already covered that we will be able to check the type of block, and that will actually check the type of the final expression in block. So that's fine. That to do already covers everything we need to do here, we think, maybe. So let's run our tests and see what fails next. Now we get to line 180 and see that hasn't been implemented either. And that is, okay, it's the type checking a mutation of a variable. So when a variable gets modified. So I think we're going to take that next time. Hope you enjoyed and see you then.